At a university, the masses of some students could be modelled by a normal distribution with a mean mass of 72 kilograms and a standard deviation of 6. 8 students are chosen at random. Find the probability that a mean mass is A, less than 68, B, between 69 and 73, and more than 74 kilograms. Okay, so we introduce a variable. So let X be the random variable, the mass of a student from a university. Then that X is normally distributed with a mean of 72 and a variance of 6 squared, or standard deviation of 6. These are the parameters of the normal distribution. However, we're going to choose 8 students are chosen, so therefore we have to use the distribution of the sample mean, which is X bar, is normally distributed with the same mean of 72, but this time the standard, the variance becomes 6 squared over 8, because they're 8 in the sample size. So the sample mean parameters are mu and sigma squared over n. Now, the sigma squared over n, or the square root of it, and this is what's important, because on the calculator this is what you will need to put in. The standard error of the mean will be 6 divided by the square root of 8. So when it says standard deviation on your calculator for the normal distribution, this is what you will need to put in. So it's a good idea to make a note of it. Okay, to work out the probability, so X bar is 72, 6 squared over 8. Standard deviation will be 6 divided by the square root of 8. Now the probability of X bar being less than 68, I always like to draw a little sketch of the diagram. It doesn't take very long. So a normal distribution, a mean of 72, standard deviation is 6 over root 8, whereas 68 is over here. So we'll put that in, and we want less in, so we'll shade that area. Okay, so if we go to our calculator, so I'm using a TI calculator here, so I'll go to number, menu, and probability. I want distributions, and I want the normal CDF. Okay, so the lower bound will be a very low number like that. You can put it like minus 1,000 if you like. The upper bound will be 68. The mean I will need to put in as 72. Okay, and the standard error I will need to put in as 6 and divided by square root, so let's control this one, of 8, close the bracket, and then press OK. Then I get an answer of 0.02967. So going back to this, putting down a few values more than I actually need. That 7 will make that 6 a 7, so I get an answer of 0.0297 from GDC. Part B, being the probability between 69, the sample mean is between 69 and 73. Doing my quick sketch, 69 is over here, and 73 is just over here. Okay, shading, so I want that area there, because the area represents probability. So going back to my GDC, just repeating the process, menu, number 5 probability, number 5 distributions, and normal CDF. You're never going to use normal PDF. Okay, so this time I want the lower bound to be 69, the upper bound to be 73. Okay, the mean to be 72. And the standard deviation to be 6 divided by the square root of 8. We now press OK, and we get this answer here of 0.6026. So writing that down, okay, and then rounding it off, that 6 will make that to a 3. So you should write down a few values first and then your final answer. And then part C, the probability that X bar is greater than 72. Make sure you've got X bar on all of these, okay? Again, a quick sketch, 72. 74 is going to be over here. Draw a line, want more than, so it'll be this area here. Okay, so going to my GDC, okay, and then doing menu, 5, 5 distributions and then normal CDF. Okay, so here I now need to put in 74. I'll need to put in a high number here, so I can put 9e to the 999, but if you don't like that, just put 1,000, that would be enough. Just want a really high number, or even 100 would probably be okay. The mean of 72, the mean, the standard deviation being 6, divided by the square root of 8. And we press OK. Again, we get another value here, 0.17288. Writing that value down, okay, and that 8 will make that to a 3, so it'll be 0.173 from a GDC. So this has been a video to show you how to work out probabilities from the distribution of a sample mean from a population which has been drawn originally from a normal population. I hope you understand, and I thank you very much for watching.